In this session, let us understand how these addressing modes are going to be used in our daily program. When each of these addressing mode is used, which feature is going to be enabled for a programmer? Let us see. For the direct addressing mode, if you want to declare a variable, you need to have the direct addressing mode enabled in the system. The CPU should support direct addressing mode if a programmer wants to declare a variable. If no direct addressing mode, no variable is possible. That is simply because when you declare a variable, immediately an address will be assigned, right? So for that reason, we need to have a direct addressing mode available in our system if at all we want to declare a variable. Okay. Indirect addressing mode, you know that the pointers, of course, if you want to utilize the computer system has to be facilitated with the pointers, then it has to be facilitated with a indirect addressing mode. That is, if a programmer wants to use a pointer, then the system should be provided with indirect addressing mode. Okay. And then implied addressing mode, there is no specific use for a programmer for the implied addressing mode. That is system reserved addressing mode. As I told you that every time when an instruction is going to get executed, accumulator will get updated, right? This accumulator will directly get updated in the single accumulator organization. But in general register organization, accumulator cannot be an implicit register, because in the general register organization, instruction will have two operands such as a comma b. At that time where accumulator is getting updated, let us have a look at here. Now here in the single accumulator organization, we do have only one operand, right? That is add 450. So accumulator is equal to accumulator plus m of 450, right? Okay, m of 450. But when it comes to general register organization, the scenario will be different. One instruction may have 2 or 3 operands, such as 450, 550. Here I do have 2 operands available in the instruction itself. So at that time, one will be the source and the destination, and one more thing will be just the source. Here, accumulator cannot be implicit. Okay, but still, in every processor, there is a necessity of updating the accumulator at the end of every instruction. Either it is a single accumulator organization, or it is a general register organization, or even in the stack organization, accumulator should be updated, because accumulator is going to give you the status of the program. The status of a program can be represented in two registers. That is, the output value of an instruction will be loaded into the accumulator, and this output value of an instruction is also going to update a flag register. So for that reason, accumulator should be updated in any of the processors. Either it could be single accumulator or it is general register. But in single accumulator, accumulator is a default second operand. But in general register, accumulator you can't see in the instruction at all. So in the general register organization, in order to update the accumulator, we use implied addressing mode. These instructions, all the register reference instructions, are going to update the accumulator. That is, if you can understand this in a nutshell, implied addressing mode will update the accumulator. Okay, in order to update the accumulator, I need to use implied addressing mode. Okay, of course, if you people can sensibly think, immediate addressing mode is for constants. All right, here, what is a constant? Constant is a specific value. Constant cannot be an address. Okay, so immediate addressing mode, if you want to declare constants, then you need to be supported with the immediate addressing mode. Okay, if you want to implement constants in your program, first of all, you need to ensure that the system is going to provide you with the immediate addressing mode. Okay, then register mode. I told you people several times that if you want to update a variable, first of all, that variable must be transferred to a processor's register. If you want to update A should be transferred to some process register, say R1. Then R1 is equal to R1 plus 1. That is, A is getting updated, right? You want to perform A plus 1. For that, get it transferred to R1, increment R1, finally transfer R1 back to A. Okay, for that reason, we want to have a register addressing mode. Okay, so every time when you want to update a variable, a value of a register must be updated, which is corresponding to that variable. So updating variables, the program which has variables and the variables are needed to be updated, so it must be supported with a register addressing mode. Okay, then register indirect mode and auto increment mode and auto decrement mode is for loops. Okay, what is auto increment? Auto increment will increment the contents of the processor's register, right? The register indirect mode, R1 is going to be specified. After performing the operation, R1 will get incremented, right? But in the auto decrement mode, before you performing the operation, R1 will get automatically decremented. Did you get it? This auto increment or auto decrement, where you can see, of course, as you interpreted rightly, this will happen only in loops. If you want to enable loops in your programming language, the system should support auto increment or auto decrement addressing mode. Okay. Now, a relative addressing mode. These relative addressing mode or base register addressing mode are typical. These are used to relocate the program dynamically in the memory. We will talk about these three in a short while. Okay, let us have a look at. Try to understand. There is a base register in the system. There is a base register in the system. Now, a program, let us say you have written a program. That program is of 100 instructions. Okay, you have written a program. A program is of 100 instructions. Okay, in which you want to branch from one location to another location. Did you get it? That is, from 5th instruction of the program, you want to branch to 26th instruction. Okay, from the 5th instruction to 26th instruction, you're going to branch. Okay, stay focused and understand here. Your program is 100 instructions. The program is 100 instructions. 100 instructions. Okay, which means that in your program, the addresses are from 0 to 100. Okay, where 0 represents the first address and 100 represents the final address. This is within your program. Okay, your program is of 100 instructions once again, and when you write a program, as there are 100 instructions within your program, the addresses will be from 0 to 100, right? But now, this program must be executed from the main memory. You can't execute the program from anywhere else. When you load this program in the main memory, this program can be loaded dynamically anywhere, right? It cannot be loaded from the 0th location. The program can never be loaded from the 0th location. Did you get it? So, try to understand. This program is getting loaded from 436th location. That is, program's base address. The moment the program is getting executed, immediately the program will get transferred to the main memory, and operating system decides to give the base address, that is 436, from which the program is being loaded. Did you get it? Now, what you have written, this is the 5th instruction of the program. In the 5th instruction, you want to make a branch to 26th instruction. What is this 26th instruction? This is the 26th instruction within your program. You want to branch to the 26th instruction within your program. Okay, try to understand. How I can branch right now? Because if I say branch to 26, simply without using any other addressing mode, program control will take me to some 26th location, right? Let us say this is 26th location. But is this a part of your program? This 26th location is not a part of a program. So what will happen? If I go to 26, operating system will terminate me, because the program base address is 436. The program size is 100 instructions. So I need to be within 436 to 535. Only 100 locations are assigned to me. Okay. A program cannot use any other space in the main memory apart from the space that is provided to the program within it. Okay. That means I am provided with 436, so on. When I try to access any other address than 436 to 535, then operating system will kick me out. I should use only the addresses between 436 to 535. Okay. So for that, a base address, the program base address will be stored in a register called base register within the CPU. Now, in order to branch to the specific location within the program, I'm going to use the base register, relatively for the address part of the instruction. What I'll do is, if I add the address part of the instruction to the base register's contents, then I will be branching to the appropriate location. I want to branch to 26, but can I branch to 26? I can't branch to 26 because 26 is some different location. 26 might be falling under some different program. A program cannot access any other program address space. So when you want to branch to the specific locations within your program, I may use a base register addressing mode or a relative addressing mode. Let us see base register addressing mode. In the base register addressing mode, the address part of the instruction will be added to the contents of the base register for an appropriate branch. So this 26 will be added to 436, which will take me to 462. This is the 462 address of the main memory and 26th location of my program. 26th location of my program. Okay. That is the thing. So when an address part of the instruction will be added to the program's base address, which is available in the base register, we will be branching to the appropriate location within our program. That is the thing. This can also be accomplished by using a relative addressing mode. What is a relative addressing mode? Anyhow, we do have a program counter that is 441, right? I can use program counter also to direct me to 462. Okay. So at that time, what I will have to do is, when I add program counter and address part, I should be able to direct it to the desired location. So for that reason, I need to construct the address part such as target address minus program counter value. What is target address? The target address is 26. Yes, no? For program counter value 6. Yes or no? In my program, when it is started from 0, 0, 1, this is the fifth one, program counter will be 6. Where I am branching? I am branching to 26. Did you get it? So what I'll do is, I will design my address part of the instruction in such a way that when it gets added to the program counter value, I will be directed to 462. Okay. So for that reason, what I'll do is 21. That is 21 plus 441 is equal to 462. So I'll use the program counter and address field relatively to branch to the specific location. 21 plus 441 is equal to 462. In your program, this is the fifth instruction. This is the 21st instruction. 21 plus 5 is equal to 21 plus 5 is equal to 26. So in such a way, we'll be branching to those locations. Did you get it? 1, 2, 3, 4, 5. This is 6. 21 plus 6 must be equal to 27. Anyhow, we will use this program counter value plus address field of the instruction to branch to the specific location within the program. Okay. So this is what the program will do. In order to have this program relocation done dynamically, we are going to use either base register addressing mode or a relative addressing mode. Okay, that is the thing. And then there is something called index register addressing mode. Base register addressing mode and index register addressing mode, definition part will be equal, right? Because we are adding the contents of either base register or index register to the address part of the instruction. Okay, but the implementation is different. Index register addressing mode is used to implement arrays. Index register addressing mode is used to implement arrays. Okay, so whenever you declare an array A of 100, immediately within the main memory, some 100 locations will be provided, in which index register will be provided with the base address of the array. Okay, I will write it here. There is something called an index register. Index register. Okay, now this is index register, XR I will say. Okay, now let us say an array has been implemented from 100 to location. Now I want to access the fifth element of the array. So 100 plus 5 is equal to 105, in which the fifth element of the array is available within the main memory. This is how practically each and every addressing mode is going to be utilized to enable several features of the programs. Okay, so just have a revision this video, so you're going to completely get these things injected to your brain, because this is important. Sometimes in many of the gate years, we have seen the questions which are based on addressing modes. Okay, most of the times we will be asked about the implementation purpose of this addressing modes. Okay, that's it for this session. Thank you.